So as I said before, I'm just going to go through the process that you should have followed or you were expected to follow. So I'm here in the link I shared with you for the Jupyter Notebook on Colab. So the first thing you had to do is you go to File, Save a copy in Drive, which is this option here. And this is going to create a copy in your own Google Drive. Once the copy is created, you can open it in a new tab or here itself. So now I'm going to close that original notebook, which is read-only. And here I have the one which has been renamed as copy of the notebook. So I'm going to scroll down because this is everything we covered in the last session. And here we are in the homework. So the first thing I asked you was write an algorithm to print a square of a given length made with x, with character x. So for instance, a square for length 3 should look like this. I know this is not a square, but let's just assume it is a square. A square of length 1 should be one single x. So the algorithm would be something like, I don't know, print x k times, print, well, let's say, so this is the action you need to do, and then on top you could say that the algorithm would say for I in range from 0 to k, just a second. I don't remember how to mute people, but please, we are listening to some keyboard. So please mute yourself if you are not going to speak. For in range 0 up to k, print x k times. And after that, print a new line. So this is an algorithm. Most of you, the ones that I reviewed, actually wrote the code itself already. So the algorithm is just telling in kind of simple words what your code is going to do. So for this range of values from 0 all the way up to k, I'm going to print character x k times. And after I print that, I'm going to print a new line. Okay? So once we have the algorithm,
excuse me.
yes.
I wanted to ask, when I look it for the answer in internet, I've found I in a range, but I'm not sure what this means.
Okay, we are going to have a look right now. So now we are going to convert this into code. So I'm going to say for I in range, this is already Python. Let's say 0, k. We are going to print x k times, which is roughly x times k, and that's it. Now, one thing I haven't done is I haven't defined k. So let's say k equals 5, for instance, and let me execute it. Okay, it worked. So let's go step by step. I initialize k, and then I create my for loop. I is going to be an integer, which is going to take the values of this function in each iteration. And for all the possible values generated by this, it's going to print something. It's going to execute whatever is inside. Now, you were asking, what is this range 0k? Well, if you don't know what something means, just execute it. So, for instance, let's print range from 0 to 5. And if we execute it, sorry, this one doesn't work very well. Let's say for I in range 0 to 5, print I. And let's see what the result of this is. So the function range is something called an iterator. The first parameter is the starting value. The second parameter is the ending value of the range. So this is why if I go for I in range from 0 to 5, I'm going to, with this print, I'm going to get 0, 1, 2, 3, 4, but not 5. This means the left value is included, the right value is not. If I want to go from 0 up to 5, then I need to write 6. Okay, and there is a potential third parameter here, which is the shift. Let's say I don't want to go by one by one. I want to go 2 by 2. So I'm going to go from 0 all the way up to 6, adding 2 every time. So that's why I get 0 plus 2 is 2, plus 2 is 4, plus 2 is 6, and it's already out of the range, so I don't print anything. Is that clear now? Okay, I assume the answer is yes. So this is exercise 1.
Yes, Alberto, I have a question. In the previous example, when you wrote down 0 and 5, and 5 was exclusive, only 0 inclusive. So there you didn't have like the multiplication of 5 as you have here when you write 0, 6, and 2, and 2 is the multiplier.
Yes.
I
So 2 is
don't
not
understand how the software like understand that.
okay. So I don't hear you very well, but I think I got your question. So 2 is not multiplying, is the shift. So the first value is going to be 0, and the next value will be 0 plus 2.
Hello?
And it's going to become 2. In the next iteration, it's going to be again plus 2. So that's why we have 0, 2, 4, and when it's equals to 6, it doesn't work any longer. If I write 7 here, I'm going to get up to 6. So this is the lower boundary, inclusive, the upper boundary, exclusive, and the shift. If here I write 10 for some odd reason, I'm going to get only 0 because in the first iteration I do get a 1 and I enter here and print. In the second iteration I have 0 plus 10. 10 is higher than 7 and it doesn't enter any longer into this part of the code. Is that clear? Yes.
I didn't remember we covered the range command, so I did it another way and it works, but I don't know if it's wrong or not.
Okay, how did you do it?
I'm sending it in the chat, hoping it works.
So Sylvia, you did for X in Y. So what you're doing here is you're multiplying 3 times the string first. Oh yeah, so what you're doing here is a bit odd. So what you're doing here is iterating over the string. So what you're, this Y, this is equivalent to doing this. Let me show you. For I in if I do this and I print I, this is what I'm gonna get. You are doing something very similar to this because when you iterate over a string, what you're doing is you are taking all the values. If instead of XXX I say ABCD is going to be more evident. ABCD, sorry. So ABCD, you are iterating over the different characters of the string. And that's roughly what you're doing here. If you want to get sure about how things are operating, something that you should do is just print Y here, or print X here. Is there some other question?
Yes, I have a question. When you showed the solution of the second exercise, yes, so I could not understand very well how this code works. So for I in range, it's between 0 and a key, which is the variable, and
Yes.
that's okay. Print X is the symbol, so what it print. This asterisk key, I understand it's a multiplication, but I can't see always it's possible that it changes the line.
Because
It's not in the same line, but 5 times x, and then it went in another line.
okay, got it. So print by itself, the behavior is producing a new line at the end. So if I just execute this, you don't see it, but there is a new line here. To make it evident, let me print whatever message. And let me print something else later on, because again, it's not evident. So these are two print functions. See, I didn't write any line break. It does it on its own. So this is already the behavior, the standard behavior of print. You can change it.
Okay.
But by default, print is going to write a new line at the end.
Okay, now I understood. So the first cycle print x 5 times.
There's one.
The
This
second
one, yes.
time, the second line. Okay.
Correct.
Now I understand. Okay.
Correct. So to wrap up, when I equals 0, we print this. I equals 1, we print all of this. I equals 2, we print all of this, blah, blah, blah. I equals 4, we print this. I equals 5, we finish. Because it's already out of this range. There is a nicer way to call range, which is with only one parameter. And it's going to do exactly the same, because as I told you before, for range, we have the initial, let's say, left boundary, the right boundary, and the shift. This is optional, as you saw already, so we don't need to give this one. And if we only give one parameter, the function assumes it's this one, and it assumes that the first one is 0. So having here 0, k is equivalent to having k only. Let's go to the third exercise. Do the necessary...
I have a question.
Yes.
Where does the k come from? I think we never saw it in the first course, k.
It's right here. It's a variable.
I see it, but why do you call it k and why not x? Because I don't understand. I mean,
I can call it toy if I want. It's just a variable. And it's gonna work. I can call it UNIBO. You can call variables as you wish. And it's gonna work. Does that make sense?
Yes. Okay.
Oh.
But no, what confuses me is that we use x, and x was also used to determine integers in the course. So, you know, why sometimes we can use x and it recognizes that it's just the symbol, like here we are reproducing the symbol across. And
Yeah.
when do we use it? Because it is supposed to be a variable. I mean, you know, switching codes like that really confuses me very much.
Got it. Got it. When I say this, x is a variable. If I write this, x is a variable. If I write this, x is not a variable. It's a constant and it's a string. I can override variables. Here I'm using x as an integer, and here I'm getting rid of the integer I used to have, and now I have a string with value high. And here it's just a string on its own, as I'm using it here. I can override variables. I can name them as I wish. It's kind of anarchy here. So if this is clear, let's go to the next question. So let the user get the, oh yeah, let me borrow some code from up here just to make it faster, because it's very similar to this.
Excuse me.
Yes.
May you zoom in?
Yes.
Thank you.
Better?
Yes, or make the window bigger. Okay, thank you.
Better? Okay, so here we said do necessary modifications to let the user pick the length of the squares. So we ask for the length of the square. And then I tell, don't let the user pick a value higher than 100 or a value lower than 0. So if age is what? Lower than 0, or age is higher than 100, do something. For instance, I would say, I don't know, print wrong value. This is not super elegant, but it works. Else, okay, so now I have my condition. I check that length is not negative. So this is negative, and I check that it's not higher than 100. If that is the case, then I print wrong value and I don't do anything. I'm going to skip this because we are missing time. But eventually what I'm going to do is I'm going to simply execute exactly the same as I did before. So I'm just going to copy this. And I'm going to say for, oh, this was, well, it's okay. I can keep the name age. So otherwise, for I in range age, print x age. Let's see. So length of the square, 6. There you are. 1, 2, 3, 4, 5, 6. Length of the square, minus 6. Wrong value. And it doesn't do anything. Another length of the square, 101. Wrong value. Okay? And that's it. Questions?
Yes. Why do you have 2 inverted commas for wrong value and 1 for x?
Because as we said in the last session, this is equivalent. I can write it. Both are strings. So both work. Length of the square, 7. and it works. So strings in Python, this is very odd and I don't like it, but you can define them with a single quotation mark or with a double quotation mark. And it both work. They both work, sorry.
Thank you.
Something else?
Yes, I have a question. So the I in the circle for I in range, etc. It's you don't have to write for each cycle. You have to add one to I. It's assumed.
Yes, range does it.
Okay,
As
thank
I
you.
showed here on top, but I think I deleted it already, range produces all the values. So another way of doing it will be for I in 0, 1, etc. But in that way, we cannot get the input from the user. So that's the objective of range. It produces a sequence of all the values between 0 and this value.
Okay.
So when I write 7, it computes all 7 values from 0 all the way up to 6. Some other question? Okay, let's go to exercise 4. Convert your code into a method which parameters are both the length of the square and the use symbol. So I'm lazy, and I hope you are lazy as well. I'm just going to copy this. I'm going to put it here. So check that the length is reasonable. So that's roughly this part of the code. But now the name of the variable is not age anymore, it's length here. So that's this part. Print long value and exit. We didn't see exit, but I'm just going to put it here. Exit means stop executing here. So if I get a wrong value here, I tell the user I cannot do anything with this value, and I stop executing. Now check that the symbol is reasonable. The meaning of the symbol being reasonable is the length. So here I'm going to write if length of, what's the name of the variable, symbol is different. I know I'm showing to you some new commands here. Is different from 1. Same as here. Print wrong length or wrong symbol length to be more precise, and exit. And finally, I display the square. And if I didn't make anything wrong, if I execute this, 1, 2, 3, 4, 5, 6, 7, I indeed did something wrong. Let's see. Yes, what I did wrong is that when I was copying the content, because I'm lazy, I forgot to change this variable. So I'm still using age equals 7. So I need to use the right variable here. I execute it again, and then when I call display square of length 1, it displays an X. Why? Because again, I forgot to change this. This should be symbol. Now I get the expected output. Here I get the expected output. Here I don't get the expected output, which is very interesting because exit is not working. So what I'm going to do, I'm going to put this thing inside, and I'm going to put this thing inside. So notice what I'm doing here. I'm saying if the length is wrong, execute this. If the length is correct, then go to this part of the code. Inside of that else, I'm adding a second pair if else. If the length of the symbol is wrong, then I print this. Otherwise, I'm going to execute this. So I execute this part again, and let's go to this part of the code, and it says wrong symbol because I'm giving 2 characters instead of 1. Is it clear? Do you have questions?
Yes, I have a question. I didn't understand len, what it mean.
Okay, so once again, if we don't understand anything, let's add a new code snippet. So len of 1, 2, 3 gives 3. Length of an empty string gives 0. Length of 1, 2, 3, 4, 5 gives 5. Did you get what it does?
Ah, okay. The biggest number.
No. What happened?
If you put something else than numbers, if you put just letters.
Like this? Nobody?
Well,
It counts the number of symbols in the string.
Correct. Len counts the number of characters in the string.
Okay.
So that's why here, when I'm asking if len of the symbol is different from 1, so len symbol is going to count how many characters I'm giving to this variable. Here I'm giving 1, so it's here I'm giving 1, so it's all right. Here I'm giving 1, it's all right. Here I'm giving 2. 2 is not equals to 1. So that's why I enter here and I finish. If I say equals here, which you say like this, the behavior is going to be completely different. Let's execute this, for instance. See? Now it is taking these two characters and it's multiplying this string times 5 in the function, I mean here. And now I don't have a square anymore, I have a rectangle. I have 10 symbols in each row. 10 characters. Okay?
May you show the code again? Okay, thank you. Just a moment, I have to check. In my computer, else is not accepted. There is a red line, underline. I don't know if...
Get sure that the indentation is correct. So this if is at the same level as this else. This other if is inside of the else. And the block of code belonging to that if is again inside. After that, else is at the same level as this if, sorry. And the corresponding block of code. Is there some other question?
Alberto, in the
Yes.
length function, does it count also punctuation marks?
Yes, I
Okay.
just showed it here. See, let me put 3 dots. Well, 4 dots actually. It's any character. Let me write.
Yeah, that's all right.
5
Wait,
spaces.
it's only
5.
to make sure. Okay, thank you.
So any character. It doesn't have to be a letter, a number, a punctuation mark, a space. Any character.
How about quotes?
Let's see. You mean like this?
Yes.
Any character.
Okay, thanks.
If you mean double quotes, then I need to define it different. I need to use single quotes and then this.
And how do you escape in printing?
How do you escape in print? Do you mean if
you need to escape? Yeah, I mean not in len. Sorry. Yeah.
No, not in the way how I define here.
Oh.
It just prints.
Okay, fine. Okay, so you use
now,
the one that you're not using.
But I know your question. I got your question. If I have this, then here there is a mistake. Here I have to escape it.
Okay.
Otherwise, if I execute this, it's going to tell me what's wrong here. So you are opening a string here. You are closing the string here. I don't understand what's this.
Okay, fine. Thanks.
Welcome.
Excuse me, will we have access to the copy of the notebook you're working on now so that we can go back and check? Okay, thank you.
So exercise 4 ready. Expand the method by allowing it to display rectangles. So I'm not going to do this because it's practically the same and we are running out of time. The only difference, I'm going to mention it here, is that here we have a second variable. So we are going to still go through through one length, and here the multiplication will be times the other length. So here in the parameter we had one single length. Here for the rectangle we have the vertical length and the horizontal length. So I will loop over vertical and I'm going to multiply times horizontal. The rest is identical. So it's practically this. Exercise 6, triangle. Okay. In this case,
Alberto, can I ask a question?
Yes.
When you need to specify the length of the vertical and horizontal length, in this case, you have to make sure that they are reasonable. Do you have to specify 4 conditions, or is there a way to do it in a shorter version?
What do you mean by reasonable?
You have checked that the lengths are reasonable, so you should have if vertical length is something, or vertical length is something, or horizontal length. So you should have like 4 conditions.
No, it's only 2 conditions. You check if vertical length is in the expected range.
Yeah, how do you do that?
If horizontal expected range, and that's it. It's 2. How do you do that?
Yeah.
You write this twice. One for one variable and one for the other variable.
Okay.
Or if you want to do this, you can add as many ands and ors as you wish here.
Yes, I was doing it with 4, let's say 4 length or length or length or length.
So you can do something like this, and you can keep going and going and going with the different names of the variables, obviously.
Okay.
The reason why I usually don't do this is that if you're talking about the rectangle here, let me undo this. If this is the if for the vertical length, here you can say the vertical length is wrong. And if you have a second if for the horizontal length, you can say the horizontal length is wrong. And this is more informative, because otherwise, if you simply say wrong value, the user has no idea if you're referring to the vertical or the horizontal value.
Yes, I get it.
For the triangle, again, I'm not going to do it because it's trivial. It's identical to the square, but you don't multiply the symbol by this length, but you multiply it by I. Is that clear? So it's not symbol times length, it's symbol times I every time, like this. And you get a triangle. So I wasn't kidding when I told you this takes between half an hour and 1 hour. And that's it. I'm not going to do the last one because it's, again, I'm just not going to execute it. So I was about to delete this, but because you want me to keep it, I'm not going to delete it. So if there are no further questions, It counts the number, two-dimensional object. I have no idea what you mean by two-dimensional object. Do you want to say something about that?
No, don't worry. I was just trying to clarify what you were talking about before when you said that you needed only two variables, but it's irrelevant. It was just a comment.
Okay. So let's go to the slides. So finally, after 40 minutes, we go to the slides for session 2. So you know now what programming means. Even if here it says traditional, forget about the traditional. This is programming. So you have data, in our case, the variables, the k, the age, the length, the horizontal length, and you have rules. In our case, we had ifs, we had for loops, etc. So this is the input for the program, and the output is answers. In our examples, the squares, the rectangles, the triangles. That's programming. It's that simple. Now, just to recap a bit, you know what a conditional is. So the program, the flow of the program comes this way, and you have a condition. If the condition is evaluated to true, you're going to execute a snippet of code. If the condition is evaluated to false, you're going to go this way, and you're going to execute this byte of code. Regardless of which direction you go into the same, you converge into the same flow, and you keep going. You also know what a loop is, like the for. So you go this way in the loop. If a condition is true, for instance, the value you have is inside of a range, then you go back, execute the code, and you return to the beginning. Evaluate the condition again, and if the condition is true, you execute again, as many times as the condition is true, until you arrive in one time in which the condition evaluates to false, and you stop repeating this code, and you keep going. You know what a function or a method is. So in Python, you define methods with def, name of the function, and the parameters, if there are parameters. For instance, print is one function, which the default behavior comes with one parameter, which is going to be the string you want to print. And inside of the method that you define, the body you define it just shifting to the right, like using tab, you have the code of the function. How do you call that function? Well, you simply call it by its name. Name of the function, identical to the name of the signature, and you give the values for the input. So in this case, I'm saying hi for input 1 and ho for input 2. So whatever the code is going to do here inside with these variables, who knows? This is the way I call it, and I'm going to get some results. I can also call it like this. So name of the function, hi, ho. Could any of you tell me what is the difference here?
Maybe hi-ho would be referring to variables instead of those specific string values.
That's correct. In this case, thank you. In this case, I'm calling it with strings. Here, I'm calling it with existing variables. Obviously, somewhere in the code, which I am not showing here, I define hi equals to something equals to something else. I decided not to execute, but I'm just going to you here. So here I have variables. The first variable is called greeting inputs. And this variable is a new kind of variable. It's not an integer, it's not a string, it's a set. And it works as sets in mathematics. So we are going to have one item of all the definitions here. So in this set, I have a number of strings. Hey, morning, evening, hi, what's up, and hello. So it's like a bag, which has all these strings together. Next to the set, I'm defining something called a list, which is, again, another new kind of variable which contains a number of values or a number of strings in this case. So I have hey, how are you, not, hello, how are you doing, etc. The difference between a list and a set is that the list can contain the same symbol more or the same value more than once. You can see here, well, you don't see it here, but if I had only hello quotation mark and hello again here in a set, it's only going to keep one. Advantage of a list, you can query the list of a set, you can query it in a very efficient way. There is something called hash function. You don't need to know, just keep in mind, querying a set is much faster than querying a list. After I have defined the two variables, a set and a list, I create a method. A method is called generate greeting response with one parameter, input. So what I'm going to do is, for every token in the input, notice that I'm using a new thing here. Input is a string, but a string on its own is a class, and a class has a number of methods implemented. In particular, when you have a string and you apply split to it, it's going to do precisely that. It's going to split it. What am I talking about? Well, as usual, let's go and have a look. Let me create a new code snippet here. So let's say my string is equals to hi, hello. And now I'm going to split, sorry, hi dot split. I have hi, comma here on the left and hello on the right. That's because the default behavior of split, which means when I don't give any parameter here, is splitting the string on the basis of spaces. So if I had another space here and I execute it again, now the output is a list containing hi, comma, he, low. If I want to change the behavior of split, let's say I want to split on the basis of a specific character, an age, for instance. So here on the left, I have a space, and that's precisely what I got here. On the right of hi, I have I, comma, space, age. So that's why I'm getting this here. And then after the second age, I have E space LLO. And that's what I get here. Okay, so back to the code. I'm going to split the input given by the user, and I'm going to iterate over it. What is that? So instead of doing this, I'm going to do here for x in whatever I'm getting here. What happened? Split. Yeah, that happened. I'm going to do something. Print, I don't know, x, just to keep it simple. So I'm splitting again, but rather than just getting the list as an output, I'm giving it to x, to the iterator. So in the first iteration, it's equals to space because it's this space. In the second iteration, it's all of this, and I print it here. And in the third iteration, I have it here. So I'm going to iterate over all the tokens in this input. And if I find that one of those tokens exists in my greeting inputs, I'm going to randomly choose one of the values in the greeting responses, and I'm going to print it. So as I already say, greeting inputs is a set, greeting responses is a list. So if I call this code, again, I don't want to execute it because I want to show you how to read code without having to execute it. So I call my function with hi. So when I call it, input has the value hi. I split that input on the basis of spaces because this is not defined. So there's no space. I'm going to return only high, only one instance, high. So token in the first and only iteration here contains value high. High is in greeting inputs. Let me see. Hey, morning, evening. Yes. The answer to this if is yes. In is asking, is this value that I have here available in this set? Because the answer is yes. This condition is true, and I go inside of the if. So what I'm going to do is I'm going to return a random choice. Forget about what this means. I'm going to choose randomly one of the values here in greeting responses, and I'm going to return it to the user. If I say ciao, again, I'm going here, input now is ciao. When I split this input, I get only ciao. Is ciao in greeting inputs? No, I'm not going to respond anything. So this is already a method to greet people. A rule-based method is not super efficient. It's super faulty, but it works. If you feel curious, once you get the slides, which actually you can get already from the GitHub project, copy this code, paste it into your Jupyter notebook, and execute it and start playing with it. If there are no questions, is there some question about it?
Alberto,
Okay.
Yeah, Alberto, can you say again what the token.lower part means? The lower part means. I didn't get that.
I'm not going to say it. I'm going to show it to you. So it's token.lower. Let's say my token, let me add a new code snippet. Let's say my token is equals to hello. Well, let's do something. Let's say token is equals UNIBO, and let's do token.lower. It looks like it doesn't do anything, but let's try changing it. So let's say here I have UNIBO, and this is what I get.
Okay.
So what does it do? It lower cases the input, right?
Yeah.
So if I use all uppercase, I get all lowercase. If I don't have numbers, somebody's taking pictures with the microphone on, so please switch it on. If I give numbers, it doesn't do anything to the numbers because there's no lowercase version of numbers. If I write here upper instead, everything is uppercased, right? So these are a number of methods that you can apply to text. Why am I doing here? Because if here I don't write high, but I write high with uppercase, I wouldn't find a match here. And I would fail to greet the person who is telling me hi with uppercase or uppercase H, lowercase I. So usually when a person is going to compare strings, you usually lowercase everything to avoid this kind of mistakes. There was another question.
Yes, I had a question. It's about writing a word. It's not in the greeting inputs. For example, ciao. Ciao is not here. So if you type ciao, the output is ciao.
No, if you give ciao, there's no output.
Ah, okay.
Because you will never find it here. Here, this every single time this is going to be false. So it's not going to enter here, and it's not going to return anything. If I write else here, I could write here else return input. So in that case, it's going to return the whatever the user wrote.
Alberto.
Yes.
Quick question. Would the match be with the whole split input, or does it also match partial input?
Okay.
I don't know
if I get your question, you mean what if I write, if the input is, let's say, hi, how are you? So the question is if this is going to match.
Mm.
Yeah, the answer is yes, because my model, my method, sorry, is going to split this
with a space.
It's going to evaluate all these values. See, it's going to ask is high in my set, yes or no? Is how in my set, yes or not? Is R in my set? Is U in my set, yes or no? And high is there.
If we used for token in input rather than in input split, it wouldn't match.
I didn't understand the question.
Sorry, for token in input dot split. If we only had for token in input, so no splitting.
Yeah, it wouldn't
match. Okay.
No, it wouldn't match. Absolutely
right.
not.
Okay.
Is there some other question? Okay, let's go to the main topic today. So there is this very famous computational linguist called Kenneth Church. He's in some university in California, I don't remember. And many years ago, he wrote a very interesting paper called Unix for Poets. And it was a number of instructions that he wanted to teach to linguists to use computers to do their research, their linguistic research. I'm not going to show you Unix for Poets, but if you're curious, you can Google it and you're going to find the original paper. Instead, I did a kind of translation from Unix for Poets into Python for Poets. And that's what we're going to see here. Don't worry to write this URL. It's going to be in the slides. As usually, I want you to pay attention to the screen. So I'm just going to minimize this. And if this thing works, it's connecting. This is what you're going to see. So as usual, I'm going to go to File, save a copy in my drive. And once it's done, I'm going to open it here. So here it is, your Python for Poets Jupyter notebook, sorry. So some quotations from the paper from Kenneth Church. So many researchers have more data than they know what to do with. Researchers believe that they don't have sufficient computing resources to do these things for themselves. So I've heard very, very often, like, oh, this is very interesting, but you need programming, so we don't do it. No, I'm going to show you very simple instructions for you to, if you need to count things, if you need to find something in your corpus, it's super simple. So I'm not going to read all of this. You can read it on your own once you get the copy. But here I'm using, I'm just going to base this experiment or this. Actually, you don't have to Google it. You can read it here. Here is the original paper, and here you see it's a bunch of bash instructions to do a number of interesting stuff. So let's just do it in Python. One thing that a new thing that I'm going to show to you here is I'm going to load a corpus. So we're going to load an input file, a text file, which is going to be Genesis. It's a copy of Genesis from the Bible. And we are going to perform some operations on Genesis. So to add a file, to upload a corpus, remember we are here in the Google space. So I need to upload the files I want to work with. So here you can see on the left, there is an icon with a folder. If you click on the folder and this thing connects, it's connecting. Yeah, connected. You can upload files. So I'm going to go into my, why are you doing this? No, now. So I'm just going to go to my local folder. Don't worry, I'm going to give you the Genesis file eventually. So this is a standard TXT file which contains Genesis. So I'm just going to upload it. Notice this is important. When you upload a file and you get disconnected, the files are deleted. So whatever you do to a file, if you create new files with your Python code and you want to keep them, before logging off your Jupyter notebook, download them back into your local file or store them somewhere else. So now I have my file here. I just uploaded it. I have genesis.txt here, and now I can start executing things on it. So let me close this. The first thing we're going to do in this first exercise is we are going to count the words in a text. So I'm just going to read the problem. The problem is I have an input text file, and the output is going to be a list of the words in the file with the frequency of the words. And that's it. And this is the algorithm. It's not really 3 steps, it's 2 steps. I want to tokenize the text into a sequence of words. That means I'm going to break them on the basis of the spaces, for instance. Later on, I'm going to count the words. There are many tools in Python to do it. Don't worry, we're going to look at them in a second. For instance, you can use a dictionary or you can use a counter. And step 3 that I didn't write here is you print the stuff you are doing. So there are a number of libraries in Python, for instance, re, and this is a library for regular expressions. If you followed, there are a number of courses here in the master's program that do cover regular expressions, so I'm not going to go in depth into them. But I just want to show you that this is the way to import a library in Python. There are functions like print, if, else, which belongs to the core library, so you don't need to import them explicitly to use them. They're just there available for you. But there are some others which are optional, and you need to go and load them into the memory to be able to use it, and re is one of them. So the way to import a library is import re. So I'm going to execute this block of code just to make it available, and later ignore this block. I'm going to open the file I just uploaded. The function here is open. The first parameter is the name of the file, and the second parameter is what do I want to do with this file. R means reading. W means writing. So here I don't want to modify the file. I just want to read the contents. And the next of the rest of the command says whatever you give here as an input, load it into the variable called input. With is telling Python, once you complete this block of code, close the file. So keep a copy of the file in memory, but the actual file, close it. Because in programming, you need to open and close files. If you keep it open, it's dangerous. You use a lot of memory, and you could run into trouble. So open the file, read the contents, add the contents into variable input, read the contents here, store them in variable txt, and close the file. So now I do have I have a copy of the contents of txt, but I don't have the file open anymore. Now that I have txt here, let me, before we go to actually execute this, let me just print txt. What happened? No such file or directory. I did something wrong when I tried to open this. I realized what I thought it wasn't. Let me restart the runtime. So now I have a fresh notebook. I'm going to upload Genesis again. And now Genesis is here. And let me try to execute it. Yeah, there it is. So as I told you before, this is just a file containing Genesis, the full Genesis document. So I'm just going to close this. I just wanted to show you what's the output of this. So in txt, now I have all the contents of Genesis. So what I'm going to do now is I'm going to execute a regular expression. The library regular expression has a method called findAll. The parameters for this method is the regular expression I want to apply and the text I want to apply it to. So the text from Genesis is the second parameter, and this is my regular expression. Let me execute it for you. Ah, wait, I forgot to execute this. I reinitialized the notebook, but I didn't re-execute this. There you are. So now in tokens, let's see what exactly did we get. We have the same Genesis text, but now it is tokenized. It is the book of Genesis, chapter, blah, blah, blah. In the beginning, when God created. This regular expression here, what it's doing is it's finding every single sequences inside of the text, inside of Genesis, which is one or more occurrences of uppercase letters from A up to Z and lowercase letters. Again, from lowercase a all the way up to Z. So this is why this is not a perfect tokenizer, obviously, but it does give you every single word in the corpus. In this case, Genesis is our corpus. So in one line, or actually in 2-3 lines, I import the library, I open my corpus, which in this case is one single file. I execute my regular expression to find all instances or all sequences of characters which contain uppercase or lowercase letters. And I get all the tokens. So I just wrote a tokenizer. Is that clear?
What
Yes.
does the plus mean in this context?
What? Say that again.
The plus.
Yes.
Yes.
The plus here means sequences of one or more letters. If I delete, let me insist with this. If you don't know how something works, what without the plus, and let's see what happens. So now I have one single character. Here it says we know what it is. So it is the book of Genesis. So when I write plus here, I'm saying sequences of one or more characters together. So what's going on here? Let me execute this again. If we open the file, I showed it to you before, but if we open the file, you will see that it contains the space, book space, of space, Genesis space, chapter space, and a number, and something else, and then in space, the space. So because I'm telling Python, give me all sequences of uppercase and lowercase strings, which length is 1 or higher, I'm getting all of this, all the words in the corpus. So is it clear now what the plus is doing?
Yes.
Yes, thanks.
Okay, so I insist, I already tokenized the text. So, but the problem is not tokenize the text. My problem is count the frequency of the words in your corpus. So I told you there are different alternatives. One alternative is using a dictionary, right? I haven't told you what a dictionary is. A dictionary is yet another data structure. Let's go and open the documentation for Python. This is a special data structure which roughly works like this. When you define a dictionary, it's like a list, but rather than having only single values, you have pairs of values. The value on the left is your key, and whatever you put on the right is the value associated to the key. So key Jack has a value of 4098. It's a number, actually, it's an integer, 4098. And key shape has a value of 4,139. So here I'm creating a new dictionary. In this line, I'm adding a new value to the dictionary. So now key Guido, which is Guido van Rossum, the guy who made Python, has associated a value 4,127. So if I execute the dictionary, if I call it, sorry, I get all keys associated with the values. And if I want one single value, let's say I want the value associated to Jack, I get 4,098. So it's very similar to a dictionary, the dictionary you are used to, right? So you have a word and you have an associated definition, and it's a one-to-one relation. Well, it could be a one-to-many relationship, but let's say, to be simplistic, it's a one-to-one relationship. Word, definition. In this case, it's key, value. Back to the notebook. So here I create an empty dictionary, and you create dictionaries with these curly braces. Remember, you create sets with standard parentheses, you create lists with square brackets. To create a dictionary, you need to use curly braces. Now, you know what this thing is doing already. I have a list of tokens, and I'm going to iterate. For every token, which here I'm calling toc, my variable, for each value in my list of tokens, here I have an if. Pay attention to this if. If the token I have in this iteration does not exist in my dictionary, so going back to this, let's say I have Jack and Sape, and I have an if saying, is Guido in my dictionary? No, because I only have Jack and Sape, so do something. If my token in that iteration is not in the values or in the keys, sorry, of the dictionary, then I'm going to add a new key to my dictionary, which value is, or which content, sorry, is whatever toc has at that iteration, and the value I'm going to associate to it is going to be 0. After the if, whatever happens, I don't care if this is true or not, it's already out of the if. So whatever happens here, I'm going to add 1 to the associated value to that key in the dictionary. And that's it. So I'm going to execute this. Now I have that according to this code that I wrote, that appears once in the corpus, sorry, book appears once, chapter appears 50 times, so I guess there are 50 chapters in Genesis. That appears 2,333 times, blah, 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 blah. Angels appears 4 times, early appears once, grandchildren appears once, bulls appears once. Doubts about this way of counting?
It separates uppercase and lowercase, I think, right?
Correct. Because for the code, this means nothing. The code doesn't know that uppercase da and lowercase da are the same. We humans know. But for the code, this is just a string with 3 characters. And uppercase T is not the same as lowercase t. Is there some other question?
I have a question. After the D, there are the parentheses. May you explain their meaning?
This one here?
Not before, in the first line.
Here?
Yes.
So, as I told you before, let me create a new code snippet. If you want to create a set, as we said before, let's say 1, 2, oh, sorry, 2, 3, 4. This is going to be a set. Let me just print it here. Print var, and we get, oh, it's not a set. There's something wrong here, but forget about it. That's not important here. I get all the values. I shouldn't get this tree. I'm doing something wrong. But that doesn't matter now. If I write square brackets, this is going to be a list. And if I write curly braces, this is going to be a dictionary, and this should trigger an error. No, it doesn't trigger an error. But to make it a dictionary, let's say I have a 5 here, and I have a whatever here, and I have something here, and I happen to have 4 here, and I happen to have, let's see if this crashes. So these curly braces are telling Python, this thing here is a dictionary, this variable is a dictionary. So to key 1, I have an associated value 5. For key 2, the associated value is this one. For key 3, it is this one. For key 4, it's this one. Okay? Notice that here I have one key associated to this value, and I have the same key associated to this value. And I told you this is a one-to-one relationship. So what's going on here is that I'm overriding this first value I have here, and I'm assigning to the key 3 this other value here. So that's the meaning of these curly braces. I'm telling this variable d is a dictionary. What's a dictionary? It's a collection of key value pairs. The key is the one on the left of the column, and the value is the value on the right of the column. And the commas just separate the different pairs. Is it more clear now?
Yes, thanks.
Okay, is there some other question about this code snippet?
Can't we write dots lower somewhere so that it merges uppercase and lowercase? Or
Yes, we are going there. We are going there. Just wait a second, please. So if there are no other questions about how to count here, I just want to insist. It was, I don't know, this is not a super nice code. I could do this in 3 lines, but in any way, in less than 10 lines, I already opened the corpus, I tokenized it, and I counted frequencies. There are other ways to count. Here I'm using a dictionary. You can also use a counter. A counter is just another module existing in Python. The second way, I told you, there is one way to import libraries, and that one is import followed by the name of the library. The second way to import a library, if you want a specific module from that library that you know already, you can say from this library, which is called collections, import this particular class called counter. When you use classes, basically what you're going to do here is we invoke the counter, having the tokens we have as input as the parameter, and whatever counter produces, we assign it to C. So let me just execute this. We roughly have the same as we had before. The only difference is that now the output here is ordered on the basis of the frequency. So this DAT 2333 times is the same as this one. And all other values are going to be exactly the same. So this print C is resulting in this text. If I want to get the frequency of one specific token, for instance, DA, I just call C with the parameter that this is a dictionary again, and I told you, you can access to specific value of the dictionary by calling the key. So if instead of that I write and here, and I execute it again, I'm going to get this value. It's the value associated to that key. If I write his, I get 550, which is this one. So let's say I want to know how many times God is mentioned in Genesis. God is mentioned 227 times. So the result is practically identical. You can code it on your own, or if there are libraries which do that and you are aware of those libraries or you find them somehow, you can just call those libraries and get the result you want. Is there some questions about this second way of counting in a list? Okay, I hope I'm not losing you. So just to show you that the result is identical, here I'm printing. I'm going to print the string counter followed by the value in C, which is my counter. It's this one I created here. I want the value associated to his in my counter. And later on, I'm going to print the string dictionary followed by the value associated to key his in D. D is my dictionary that I created here. So if I execute this, I get that the value associated to his in the counter is 550, and the value associated to his in the dictionary is 550. It's not a surprise, right? They do exactly the same. So as I told you before, there are many official and contributed libraries, so you can just import them, or you can do from the name of the library, import this particular module. Once a library is imported, you can just access the method and classes. You know now that if you want to open a file, you can use open, or with open actually. You know that there are the way to call regular expressions. Now you need to build interesting regular expressions on your own. You know what a list means. So a list is precisely a list of elements. You know what dictionaries are. They are a set or a group of key value pairs, where for each single key, for each single key, there is an associated single value. You know what is a loop, you know what is an if, etc. So back to the story. We know what tokens contains already. We know that it's all the values, it's all the tokens in Genesis, which is our corpus. So here I'm going to print three things. Let me just execute it for you. So the first print is print the full list of the tokens in Genesis. This is huge. If I go right, it's full Genesis, which finishes, I don't know, with some odd value at the end. Beginning, I guess, I don't know. If I want to know how many tokens, how many words occur in Genesis, or in this version of Genesis at least, I can simply call len, which you know already, and the output of len becomes the input of print. Genesis contains 36,551 words. If I want to find the third word in Genesis, it's simple. Tokens is a list, so I give the index that I want. If I write tokens 3, I'm going to get the third element in Genesis. Or not really, because remember, everything in coding starts in 0. So 1, 2, 3, I'm not getting off because it doesn't start at 1. It starts in 0, 1, 2, 3. And that's why here I'm getting Genesis. If I instead write token 0, I'm getting that, which is this guy here. Now I can start playing and I can start trying to find interesting things here. I'm going to make a loop in range. We know already what range does. So from 0 all the way up to 20, I'm going to loop and I'm going to print the value of I together with the string I have in my list at position I. So if I execute it, I get 0, the, 1 book, 2 of, 3 Genesis, etc. So all the way up to A, which is word number 29. There's no magic here, right? we already covered all of this. We know what range does. We know what I is doing, what values I are doing, and we know that when we have two different variables and we put a comma in print, it basically prints the first value followed by a space followed by the second value. And if I write here yet another value, which let's say is hi, I'm going to get 0 the hi, 1 book hi, 2 of hi, etc. Let me scroll down. What happens? Let me close this to make it handier for you. Again, we still have this list. What happens if I want to see just one slice? I want to see one part of this corpus. Well, I can define a range of the list, and the ranges in a list are defined like this. Inside of the square brackets, the first value here before the colon is the starting character, and the second value is the ending character. This is kind of the same as in a for loop. So if I print this, I'm going to get from string number 0 all the way to string 6. So that 0, 1, 2, 3, 4, 5, 6, up to that. And this is called slicing. I'm getting slices from my list of tokens. And now I can do interesting things. If I write -7, which is a negative range, and I leave here without any value, let's execute it. And this is giving me the end of the list. So Genesis finishes with "and placed in a coffin in Egypt." And that's the end of Genesis. Okay? So I can create negative ranges. When I don't write anything here, it's the same as we did with range. Remember that I told you, you can write 0, or if you don't write anything here, Python assumes the default behavior. The default is starting at 0. Well, the default here, if I don't write anything, is I want the last token in the corpus, or in the list here. So because I don't know, well, I do know because I already counted this, but assuming I don't know, I just want the last 7 tokens in my corpus. I get it like this. If I do from -7 all the way to -3, for instance, it's gonna work and placed in A. If I go back from 7 all the way to the end, I'm placing a coffin in Egypt. So I can get specific fragments from my corpus and display it in case this is interesting for me. Actually, this is not super interesting, but this is just to show you how to slice list. Now let's start doing something interesting. I'm going to sort the words in the list. Let's say I want to sort them alphabetically. It's super trivial. I have the tokens, my list of tokens, and there is a built-in function in Python called sorted. The input of sorted is a list, and the output is the list, or a different list, but sorted. So let me just print this. So if I sort tokens, I'm going to get able. These are the first 10 tokens sorted alphabetically in Genesis. If I want to get the last tokens are always yourselves, and the last one is Sahab. So this starts to become interesting. Now, what happens if we count again, but unsorted tokens? It's an identical code to the one we had before, but this time I'm using the same dictionary, but I'm not counting on tokens, the original tokens. I'm counting on sorted tokens. So now I know that A appears 3 times, Abel or Abel, I don't know, appears 9 times, Abida 1, Abimael appears 1, Abimelech appears 24 times. Okay, now you were asking before, but come on, that with uppercase and that with lowercase are the same. Okay, so now we're going to sort the list, but with lower casing. if we print the text, which is something I'm not, well, let me just print the text. If I print the text, you can see I have uppercase, I have numbers, I have lowercase, etc. Let me close it. I showed you already before. If I simply lower the text, which is this method that I apply to the string, I'm going to get a new version of the text which has been lowercased. So I'm just repeating the same process as before. I'm first lowercasing, and here I'm going to tokenize my new text. Notice I'm overriding txt. Here I had the original text. Now I'm overriding it with lowercase text. So I apply again my regular expression, and I get a list of tokens. After I get the list of tokens, I sort them, and once again I override tokens, and I assign them to variable tokens. Once I have my list of tokens sorted and lowercased, I'm going to count them. I assign the output to variable C, and finally I'm going to print it. So before, I'm going to scroll up. Before we say it, where is it? The appears 2,300 times, and lowercase the, which is somewhere else, appears I don't know how many times. Just let's keep this 2,333. Now that I'm lowercasing, I find 2,474. So now I'm actually putting them all together. And again, it's that simple, right? It's just lowercasing, and I repeat the computation. Is there some doubt about this?
Alberto, can I ask a general question not directly related to this?
Yes, yes.
I'm not sure I'm going to use the right terminology, but say the lower is a function. Let's say lower is a function and sorted is a function. Why in the first case you write txt.lower, so you apply lower to txt by putting name of the variable and then dot, and in the second case you have sorted and then the thing you need to apply the function to in parentheses?
That's a very timely question. Thank you for asking that. So here I'm executing lower after txt because lower is a function which has been coded by somebody inside of Python, and it's accessible for strings. So strings are objects, and objects have a number of methods associated to them. So this lower here is a function which has been coded for strings. It belongs to strings. So whatever string I have, even if it's just, for instance, something like this, I can apply lower to it. This sorted here is different. This is a function that exists in it. Sorted here is similar to this print. It's a function on its own, and it gets something as input. In this case, we're giving a list to sort it. So that's why here I put dot lower here. If I write here dot sorted, and there's no sorted function implemented for strings, it's going to trigger an error. Same thing as if here I just write lower. If there's no function called lower here, it's going to trigger an error. This is a general function, and you apply it to a number of parameters, whereas this one is a specialized function, let's say, which is available for strings. Actually, not when I was, yeah, when I put the scroll here, you can read built-in method lower of str object. So this is a built-in method already implemented there somewhere inside of Python. This one is different. This one is a function. See, if you put the mouse on top, the pointer, it says this is a function. The name is sorted. It has some properties that we didn't see here, but it has some properties called iterable. It has a parameter called key. It has another parameter called reverse, and you call it like this, and you're going to return, it's going to return whatever. The description is there. Is that clear?
Yes. Yeah, thank you.
Sorry, I don't go into that many detail, but I need to rush. Is there some other question? Okay, if there's no other question, let's say I want to count the sequences of vowels in Genesis because I don't know, I'm interested in diphthongs. I want to study the language there. So in this case, I'm going to change my regular expression. Instead of asking for all sequences of uppercase A to Z followed by upper or lowercase a to Z, now my regular expression says, I want all sequences of vowels, sequences of length 1 or higher. So I'm going to find all those sequences and I call my counter. If I execute this, it tells me there are 15,000 occurrences of sequence E, 10,000 or 11,000 of sequence A, blah, blah, blah. And here we have a diphthong. OU appears 1,800 times, and EA occurs 946 times, and OO occurs 282 times, blah, 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 blah. So again, 3 lines of code, and I already got all these countings just by changing my regular expression. What if I want to do the other way around? I want to count sequences of consonants. Well, I change my regular expression again. I want sequences of all possible consonants, and I'm going to count. So TH this is not surprising. TH is the most frequent sequence of consonants, occurs 5,000 times. S occurs 5,000 times, blah, 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 blah. Questions about this?
I have a question about this. Maybe I can't see it because there is the windows is not so big. But I was wondering, so group of 1 consonant, 2 consonant, and also 3, 4, 5 consonant?
Yes.
And until the maximum it's not okay. So maybe also okay 5 consonant. Okay, there is not a limit. Okay, thank you.
No, I think this works. I never remember. No, it's not like this. Yeah, there is no limit. There's a way of asking for a specific number, but I don't remember how to do it. Maybe like this. No, forget about it. There's a way to ask for a specific number. If I don't say anything, obviously I'm going to get only sequences of one character.
Alberto?
Yes.
Okay, thank you.
When it counts the sequences, it
Yes.
starts counting with sequences that have several symbols in it down to 1 symbol.
That's correct. So if I get your question, the T that I'm counting here is not going to be counted here. So this T is not included in this TH. Is that your question?
Mm-hmm. That?
Yes, yes. It goes from longer to shorter.
Okay.
So, welcome. So these 2 examples are intended to show how easy it is to change the definition of what counts as a word. So we counted all sequences of characters, of letters, sorry, sequences of vowels, sequences of consonants. So let's just skip this. You can read this later on, but let's start doing something interesting. So you know already how to sort in dictionary order. I showed it to you already, but so let me just execute it. I'm starting again from scratch. I'm reading my corpus. I'm applying my regular expression to get tokens. And finally, I'm sorting the tokens. And then I'm printing them. Notice here that there is a small difference from what I did before. I'm not counting words here. I'm counting sequences. Sorry, I'm not tokenizing. I'm tokenizing sequences of 2 words. Why? Because I have a space here, and I'm telling all sequences of 1 or more letters, followed by a space, followed by sequences of 1 or more letters. So that's why here I'm getting a river, a wild, a young, Abel, and Abimelech, and blah, blah, blah. So keep that in mind. Once again, now I'm suddenly working with bigrams here. it's fairly simple. Now I'm going to load the corpus again, but instead of getting the input as I was getting it before with just read, input, the object that you get here as the output from open, has different methods. It's the same as with the string. The string has lower, for instance, or upper. Well, input has read, which means all the contents from the file, store them in txt. If instead you call read lines, which is slightly different from read, you are not going to get the full text. You are going to get a list of the lines in the text. So this is the first line in Genesis, the book of Genesis. Notice there is a line break. Somebody was asking in the comment in the forum chat, what's the meaning of this? Well, this is these two characters together. The backslash is called escape, and escape n means new line. So the book of Genesis is the first line, followed by an empty line. It's just a line break, followed by chapter 1 line break, followed by another empty line, followed by 1:1 in the beginning when God created blah blah blah. So now txt here is not a string anymore. It's a list of strings. So something that we're going to try to do next is we're going to sort Genesis on the basis of rhyming. So before going all the way to Genesis, let's do a small example. So here we have the list of Genesis. Here I'm creating a smaller list. So this one has only 3 values. Hello, how are you? Is the first string. My name is the second string, and today is the third string. And they're all assigned to word. And let me execute this before explaining you what this thing is doing. So I'm telling Python for every W in Word. So notice here that I'm using Word here as the name of the variable, but I'm not assigning words to it. I'm assigning a list of strings. So for W in Word, print what? Print W. Remember what we had before? Let me go all the way up. Remember what we said here, that the beginning is the beginning of the range, the end of the range. Here now we are using 3 values. Here, the beginning of the range is empty. The ending of the range is empty. And now I have a third value. And this value is the order I want. So that's why in the first iteration, the input to this print is hello, how are you? But I'm telling it, give it to me in inverse order. So if you read from right to left, as if it was Arabic, for instance, it says hello, how are you? For the second iteration, W is equals to my name, and I'm printing it in inverse order. Okay? Is it clear what I'm doing here?
Yes, thank you.
Okay, now let's start playing with this. I had my tokens here before. Let me just execute this. Wait. Remember, yep. So here I'm doing a loop, but I'm not looping over text anymore. I'm looping over my tokens. And here what I'm getting is sequences, double sequences of double words. Or in said in a different way, I'm getting sequences of length 2 of bigrams. So I'm iterating over all my list of tokens, which happens to have pairs of words. Now my tokens, my definition of token is a pair of words. I'm iterating all the way up to the last -1 of the instances. And every single time I'm printing that current token, follow up to the next token. That's here I+2. So I print, for instance, here, him wandering in the is the coming token. in the man. The man is the same as here. The man ask him what are. So you can start playing with these things. Let me close this and let me go back to the example. I'm just showing you from my point of view, interesting methods. I'm going to take this again and I'm going to make it a method. And this method is going to be called invert. The input to this method is the word, and I'm going to return the inverse of the word, which is exactly what I just showed to you here. So I'm going to invert the word, and I'm going to start doing very odd things here. So please pay attention. I'm going to use the same method I used before, which name was sorted. And I'm going to give it tokens, but I'm going to add a second parameter. The parameter is called key, and the value I'm going to give to key is invert. And invert is this method here. So I'm telling Python, sort the tokens I am giving to you, but instead of sorting as usual in alphabetical order, use this function here. And this is what I get. Let me recreate tokens because here I'm using bigrams. Let me create the tokens again here on top so I get words only. Here. So now tokens, no, I did something wrong. Then I will execute it even earlier. Just a second, let me find it here. Now I have a list of single words in tokens. Forget about this one, we don't need it. Here, back where we were. I told you, I have the function sorted or method sorted, and I'm giving invert. So before, when we were giving we were using sorted, we were sorting in alphabetical order. So we would have all words starting with A, followed by all words starting with B, all words starting with C, etc. Now we have A, and right after we have God, Lord, 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 Lord. All words ending with D, and then all words ending with B, words ending with C, etc. So 4 lines of code, and I'm sorting all the words in Genesis, but in inverted order. It doesn't mean from C to A. It means from the right. Now you might be wondering, why is God and Lord God and Lord appearing before, I don't know, before A, for instance? That's because in Python and in practically all programming languages, as I told you before, an uppercase token, an uppercase word is different from a lowercase word. And uppercase words come before lowercase words. So this is why here I have these words in uppercase appearing before the lowercase ones. Is that clear? Is it clear why I'm getting this?
Yes. Okay.
Okay. So let's say you are translating something, and let's say you are translating the lyrics of a song, and you don't know which one fits better because you want to keep the rhythm and you want to keep how things sound and in summary the rhythm and the rhyming. That's the word I was looking for. Well, you can write a simple code, get the corpus from your songs, a corpus of songs, and you can get the kind of word that might fit in your translation. Now you can compute Engram statistics. I hope you know what an Engram is. An Engram is a sequence of words of length n. So if n is equals 1, a unigram is just tokens, the words in a text. If n equals 2, it's sequences of 2 words. Before going to the engrams, let me show you another interesting method that strings have in Python. Here I have an empty string, and I'm calling method join. Join has as parameter a list of values. So I'm giving 1, 2, 3 as parameters to join, and I'm going to execute it. So what join does is it takes whatever I have here, puts it in the middle of these values that I give in the list, and pastes them all together. Let me show you by adding a dot here. If my string is a dot, I'm going to get 1 dot, 2 dot, 3 dot. If I write XXX, it mixes, right? So the value here on the left becomes, let's say, the glue of the words in the right.
Alberto?
Tell me. Yes.
Two questions. One of them refers to the previous item. You were talking about lowercase and uppercase, but I missed if you mentioned combinations of uppercase and lowercase, whether they are considered lowercase, uppercase, or a third case that is in between.
For Python, this is just a sequence of characters. So if I have uppercase G followed by lowercase o and lowercase d, it's going to appear after this instance here, because lowercase o and lowercase d come after uppercase o and uppercase d. Is that the question?
Yeah. So it would be a third case. There would be all uppercase, then uppercase with lowercase, and then all lowercase.
Yeah.
Okay. My second question has to do with the item you were talking about now. Can you show it again? Yeah. Is 1, 2, and 3 parameters and can be exchanged in order, or is just the only case where it would happen? So would it join 1, 3, 2?
Of course, because these are strings.
Okay.
So let's write 3 here, and 2 here, and pumpkin here.
Okay, thank you.
So as I was telling before, your string is going to become the glue, and it's going to paste together or concatenate together, better said, all the values here. 1 is this one here, glue, triple X. 3 is this one here, glue. 2 is this one here.
Okay. Yes, just to make sure, this is something that you would apply on the corpus. Would this command apply to all combinations of these strings here in any order?
Yeah, you can do it. You can create a combiner to create all possible combinations. We are not going to do it here, but yes, you can do it.
Okay, that was my question. Thank you.
So why am I showing this to you? Because that's the typical way to build unigrams. Let's go here and try to create bigrams from Genesis. So we open the corpus as usual, read it, we lowercase it this time, and finally we get all the tokens. How are we going to get the bigrams? Instead of having triple X or an empty string here, our string now is going to be a space. We call join. And this is something super odd that I want you to pay attention to. This is like a for loop, but it's slightly different. Before, I was showing you a for that was like for condition, condition, do something. Here it's a for the other way around. I do something for some condition. But it's identical to what we saw before. Condition, as far as the condition is true, I execute this. So my loop here is going all the way from token 0 to token size of the corpus -1. So this is a counter. I is going to have 1, 2, 3, 4, 5, all the way up to size of the corpus -1. All right? So what am I doing? I'm iterating over the corpus, every single character at a time. For each iteration in that corpus, I'm going to get the token or a slice of the corpus, which is the current token, plus the next one, which is what I showed you before. Remember when I told you this is how you slice strings? When I told you from 0 to 7, and I should find somewhere here. Here, from 0 to 7. So here I get a slice of length 7, starting in 0. Now I'm not starting in 0 anymore, because now I'm using variables. I want this to be dynamic, and I want to cover the full corpus. I'm not starting in 0 anytime. I'm starting in value of I, which is 1, 2, 3, 4, 5, up to the size of the corpus -1, which is this operation here. And every single time I'm taking a slice, starting at that position, +1. Let me execute it for you, and you will see what's the result. Oh, I forgot to delete this thing. So now I have the bigrams. Bigram of the appears 335 times. In the appears 246 times. Say to appears 216 times. The Lord appears 168 times. Is that clear? Another way to do this would be saying for I in this range, do. I have an empty list here. My list equals an empty list. And here I will do my list dot append. I'm adding the new value to the list, the output of this. So these 3 lines, well, if I write here bigrams, but anyhow, I just wrote my list, these 3 lines are equivalent to this line here. Why am I showing you this way? Because good programmers usually use this. So if you go online and you look for methods to iterate over a list, you're going to see this, and you're going to get lost if you are not familiar with it. Usually people don't use this. They use this, which is called being Pythonic. Being Pythonic is using kind of the genre of Python. And this is Pythonic, and this is not Pythonic. But they are equivalent. So here, I insist, I'm getting the bigrams at once from the full corpus. I count them, and I get the counters of bigrams. Is that clear?
Alberto.
Yes.
Am I correct in saying that they are sorted in decreasing frequency order?
Yes, because counter does that.
Okay, so that's
gives you a
counter
dictionary
that does the
order by the values of the dictionary. Okay. So if I go all the way to the right, I'm going to start finding the hapax legomena, which is bigrams appearing only once, which are, by the way, the most interesting ones. Is there some other question?
Yes, I have a question. I didn't understand in this code how you indicate that you want to use 2 words together.
Yeah. So I remember what I told you about slices. Let me create a new code snippet here. Let's say I have x equals, equals. Let's make it with integers. 1, 2, this keyboard. 2, 3. Let's say this is my list. Let's make it up to 4. So I told you, if you want to get a slice from this list, you can simply do this. For instance, and you're going to get the first 2 elements, right? or you can do from 1 to 2, and you're going to get only one element. So if I want to get all the bigrams here, I will have to write from 0 to 2, from 1 to 3, etc. Oh, this is going to print only the last one. I forgot to add a print. This is why I don't like Jupyter notebooks. So I'm getting the first slide, I'm getting the second slide. If instead I say 0, 0 plus 2, notice that before I had from 0 to 2 and I got 1, 2. If now I do this, I'm going to get again 1, 2. And that's precisely what I'm doing here. I'm telling at this iteration, let's say in the first iteration, I is equal 0. So give me from 0 to 0 plus 2, from 0 to 2. So the value 0 and value 2, and this is what I get. In the second iteration, I is equals to 1. So I'm telling Python, give me from 1 to 3. 1 plus 2 is 3. So it's equivalent to this one. And that's why I'm getting 2, 3, which is the second bigram. In iteration 3, I is equals 2, and I'm getting from 2 to 2 plus 2, from 2 to 4. So I'm going to get 3, 4. This thing that I'm doing here is identical to this. But in this case, I'm doing it with a variable with the loop that I'm creating here. So I'm telling Python to get pairs of words here, and I'm pasting it with a space. Now you might be wondering, can I get trigrams? Sure. Now I have the land of, which is a sequence of 3 words, in the land, sequence of 3 words, the sons of, and I could write 6 if I want. Years he became the father of appears 17 times. This starts to be interesting. Years and had other sons and appears 16 times. Did you get it?
Yes, thank you.
Okay, welcome. Is there some other question? We ran out of time. No more questions? So for trigrams, I just gave you the solution, so you don't need to worry about. The only thing I didn't mention, give me three more minutes here. There is a mistake here, and at the end you don't see it, but this thing should crash. The reason why this should crash is because I'm going all the way from token 0 to length of the corpus -1. So at the very end, I'm trying to get a 6-gram when I can only visit bigrams.
Yeah. So
this should trigger an error. It is not triggering it because I'm not using defensive programming, and this is misbehaving. Basically, at the end, I'm getting a bigram. If you want to get trigrams, you need to subtract 2 here. So you go all the way from token 0 up to the end -2. So at the end, you're going to get the final trigram. And finally, if you want to generalize this, which means you want to use any n, instead of fixing 3 or hard coding, the actual name of this is hard coding. Instead of hard coding 2 or 3 here you can write I plus n, and this is all the way up to the n minus n plus 1. You do the math, and you will see that when we are working with bigrams, this becomes 1. When we are working with trigrams, this becomes 2. 4 grams, it becomes 3. So here, if I want to get 4 grams, I don't need to go here and change the two values. I just get them. If I want 5 grams, I just change the value of n here, and it gets updated here automatically. I don't know if I have, for instance, 10 grams. Years and had other sons and daughters, thus all day appears 8 times in Genesis. And there's some other phrases of 10 words that appear 10 times or 2 times. The rest, they are hapax legomena, which means they appear only once. Let's say you want to let's say you are a professor. Well, yeah, let me say this. Let's say you are a professor and you get an essay from your students and you want to know if they plagiarize or not. Usually you get a quotation of a fragment, and you go to Google and you find out if somebody else wrote this on the web. Another way to do this is trivial. You get all the essays from all your students, you merge them, you open them, you merge them together and count 10 grams. If there is one 10 gram that appears in 2 documents, there's something fishy. So you don't need to pay Turnitin, or you don't need to pay fancy plagiarism detectors. You can do it on your own in 10 lines of code. So I'm going to close here, and next time we're going to talk about methods, even if we already talked about them. But I want to go slowly through them. We are done, so if you have to leave, I'm going to stop recording right now. But if you have questions, I'm here. You can